Welcome to the course Business Analytics and Text Mining Modeling using Python. So, in previous lecture we were talking about functions and we talked about various aspects, and in the last part of the previous lecture we were specifically focusing on how to write more reusable and generic function. So, we talked about we took this data cleaning example where we have a list of strings and how we can get rid of white spaces, any punctuation symbols, special characters, or perform proper capitalization and all those things. So, the main focus was the same lines of code, same code block, whether it can be written in a more reusable and more generic form. So, that aspect we touched upon. So, you can see the first approach as we discussed in the previous lecture. We used built-in string methods and the standard library, and in one function in a one loop we just went through all these string elements of this list of string and just performed operation in a sequential fashion, and we had this one function. Now, in the second approach we just changed the code organization a bit, where we created where we define another function for the re sub function that we are using. So, separate function for that, and we created a list of operation, the list of function that we want to apply on a list of a string. So, in a sense we created a structure where we have a list of operation that we would like to apply, and we have a list of a string. So, we in a sense improved our clean strings function, and we are running a loop for the string, and then we are running a inner loop for different operations that we would like to perform. So, this way of writing the same code makes it more usable, because in future whenever we require to add one more operation, it would be easier to do the same in this one, because we will just have to add that operation in the clean ops variable. However, in case of first approach we will have to change the code, we will have to work that out and change the function itself. Here we do not have to change the function itself, we will just have to modify the list. In the first approach we will have to change the function. So, in this lecture now we will focus few more aspects about functions as well. So, functions sometimes they can be passed on as arguments to other functions. So, to demonstrate that we will take this example of map function. What it does, it applies a function to a sequence. So, we might have a list of elements, we might have a sequence, and this this map function what it will do, it will take any function that we pass as a first argument, and then it will apply it to the sequence that we might have. So, here what we are doing is we are running a loop for x in map. So, the map function it has two arguments in this case, remove punctuation. So, we would like to remove punctuation in the second element, that is a list of strings. So, here you can see remove punctuation, this is a function, this is being passed as an argument to another function which is map, and in the first line, one line that we have in this for loop, we would just be printing out the elements of this particular sequence that we will have. So, we will run this, and you can see the messy strings, the element that we have remove function has been applied here using the map remove punctuation function have been applied using the map function. So, if you compare this with the second approach that we had gone through, it is quite similar to that, we are applying in this fashion. So, you can see the message string, all the punctuation marks are gone. Let us move on. Now, we will talk about another aspects related to function. So, sometimes we might be required to write anonymous or lambda functions. So, these anonymous and lambda functions could be really useful when we are required to pass functions as arguments, and those functions are very short function, have just one or two lines of code. So, for passing a function as an argument and which has just one or two lines of code, we we won't prefer to have the full body of the function def keyword and the way we typically define it. To create the ease of passing on the function as arguments, we have these anonymous or lambda functions. So this is lambda functions, anonymous function. They are concise way of writing functions consisting of a single statement. So for this we use lambda keyword. So a function object itself is never given an explicit name attribute. So we won't be calling these lambda function by name. So that is why they are also called anonymous, because they won't have any name. So typically they are used when because they are supposed to have single statement. So they are typically used as function arguments. So function objects, so convenient when functions as arguments are used. So in data processing context, this is quite common, where we might have a column of data, column of observations, and we would like to perform certain operation on that column. So just one line of code would suffice to perform that operation. So for that, instead of writing the full definition, the traditional the typical definition the way we do in Python, we can use lambda function. So what happens, this becomes feasible to write and apply a custom operator also. We will see that. So you can see we are defining a sort function here, and it has just one statement, and that is also in the form of a return statement. So what we are doing is we are taking x as an argument and just multiplying it with the 10 and returning the same. So this sort function has just one statement, that is the return statement. The same thing can be written as a lambda function, where we can use the lambda keyword here. You can see ret2 is the return value, and the right hand side we have created a lambda function here. So you can see lambda and the argument x colon, and then the single line of code that we would like to execute, x multiplied by 10. So this is this is the way of defining the lambda function. Now let us run this. So this is defined. Now we will take example here. You can see we are again defining a function apply short f. So it has two arguments, a list and a sort function. So the idea is we would like to apply this sort function on this list. So what it will return, this sort function, this expression which is actually the returned expression from by applying this sort function on this in this object x, and this object x is a list element. So a loop we are running for x in a list. So let us define this as well. Now if we call this function apply sort f, you can see we are passing a list 0.1, 0.2, two elements in this list, and we instead of short f we can use here a lambda function. You can see lambda x and x multiplied by 10. So this is a convenient way of writing a single statement function. So we can use lambda keyword in this fashion. If I run this, you can see we got the output 1 and 2, a list with the elements 1 and 2. Similarly, let us take another example to demonstrate this. So let us say we have the sequence 7, this variable, and we have these 4 string values here, Shiva, chanting, Om and Nama, and what we want to perform is we want to do a sorting which is based on the length of the string. So you can see this sort function that we have used before as well, it requires a key which essentially is a function. So here we are using lambda function, and in that we are just taking the length of the string. So based on the length of the string, that would be treated as a key, and that key would then be used for the sorting. So if I run this, you can see in one go we are able to generate the key using lambda function, length of the string, and we are able to sort this list of strings here. So you can see Om comes first because of having just 2 characters, then Nama, then Shiva, then chanting. So in this fashion you can see writing lambda function or anonymous function could be really useful in the context, as you can see, when we are passing functional function as arguments, or in some situation like the way we use sort method here, certain other situations also. Now, there is another aspect related to function that we would like to discuss now. It is called currying. So, this is about defining a new function that calls an existing function with fewer arguments. So, we might have a function with 2, 3 or more arguments. Now, sometimes we might require to have a function which 1 or 2 arguments have fixed kind of value, and only the other arguments are variable, other arguments are going to change. So, sometimes we would like to define a function for that, because it might it might be used repeatedly in the future lines of code. So, therefore, we call this currying. So, let us say we have this add numbers function. So, defined as def add numbers 2 arguments x comma y, and we are just returning x plus y. So, what we can do is we can use lambda keyword here and define a new function that will have fewer arguments. So, you can see add underscore 5, this is the new function, and we are using lambda keyword, x is the argument, and add numbers we are using the previously defined function add numbers, which had 2 arguments 5 comma x. So, essentially we are adding 5 to the argument, the single argument that will be passed in the add underscore 5 function. So, from a 2 argument function add numbers, we have now we have created or defined a new function with just 1 argument, and the second argument is actually a fixed number here 5. We can achieve the same thing using partial function from the built in functools module. So, this functool modules has several useful functions. So, partial function can actually be used to achieve the same thing. So, first thing we will do is to import that module from functools, import partial this function, and here also you can see we can achieve the same thing, new function new underscore add underscore 5. So, this is the new function, and we are using partial function here, and you can see the original function add underscore numbers is being passed as the first argument and comma 5. So, one argument is 5, and we will just have to pass one more argument. So, in this fashion also we would be able to define this new function with fewer arguments. So, this is something that is called currying. So, let us run this. So, now let us call add underscore numbers, the full function that we had defined. We are passing 2 arguments here 2 comma 4. If I run this, we will get the answer 6. Now, the new function that we had defined using the lambda keyword add underscore 5. So, you can see I am just passing one argument 2, and the second one is actually 5. So, we will get the output as 7. Similarly, we had also defined a new underscore add underscore 5 function using the partial function, and here again we need to just pass on just one argument, and you can see the output 8. So, in these 2 arguments that we have, in these 2 functions that we have just created, they are actually based on the original 2 argument function, and now they have become just 1 argument function. Now, let us move forward. Now, we will talk about another aspect related to functions. This is referred as generators. So, generators are also functions, but typically they are used to construct iterable objects or iterators. As we have discussed before, in the for loop context, typically we require an iterator, so that we can whatever code block that we want to execute again and again in a repeated fashion. So, through an iterator, it might also be required in the code block itself. So, these are generators or functions to construct iterable objects. Now, when we say an iterator, so iterator is again an object that will yield objects to the Python interpreter when used in a context like a for loop. So, whenever we are using a for loop kind of context, this iterator will yield objects in a fashion, so that the iterations can be performed. So, whenever we encounter a statement like the for loop statement like for I in some sequence, the Python interpreter typically it first attempts to create an iterator out of it, iteratable object out of some sequence. So, whatever sequence for I in some sequence, so from the some sequence the Python interpreter will try to create an iterator. So, the generators these functions can also help in constructing those iterators. So, let us take an example and few more, it will be followed with few more examples to explain the whole idea here. So, here you can see we have created this dict variable here, dict object here D4, and the key value pairs A1, B2, C3, and we are running this loop. So, if I run this, you can see A, B, C, these have been printed. Here if we look at this sequence that we have defined D4, if we apply iter function to find out the iterator part of it. This is something when we said Python interpreter attempts to create an iterator. So, we will apply this iter function on this sequence and see what we get. So, if I run this and I run again. So, you can see it, this variable that we have, it says dict underscore key iterator. So, the type key iterator is actually there in the Python platform, and when we apply for loop, it actually tries to perform that. Now, if we use list function to understand the element of to see the elements of this key iterator, you can see A, B, C, right. So, the key part of the dict object that we have, they are the element of this iterator. So, the Python interpreter, it will actually create this kind of iteratable object. It will apply the type function to confirm the type here, you can see type 8, and we get dict underscore key iterator. So, this is a iterator object that Python interpreter tries to create. The same thing we are trying to convey here. Now, another way to construct these iterators is using generators functions. So, now we will talk about the same. So, now what generators typically do, they return a sequence of multiple elements in an orderly fashion as and when requested, because in a for loop context once a loop runs through, then we require the next element to iterate over. So, the generator functions will actually do the same thing. So, typically a function will return once and that call would be over. However, a generator as and when requested, it will keep on returning multiple elements one by one as and when requested. The same thing we have mentioned here. So, for this generators they typically use the yield keyword instead of the return keyword. So, let us take an example. So, here we are defining a squares function which has one argument n, default value 10, and we are printing this statement generating squares from 1 to whatever the limit is there, and we are formatting is n to the n square, and for I in range 1 comma n plus 1, you can see will be we are using return yield statement instead of return statement. So, yield I square I to the power 2. So, that would be returned. So, this squares generator would actually be yielding these square numbers right starting from 1. So, let us call this generator function. So, we are using G to store this the returned elements. So, that is done. Now, let us run G. You can see this is a generator object. If we run the type function on this G object, you can see generator. So, this type of this is a generator type of function object. Now, if I run list function on this G, you can see generating squares from 1 to 100. So, these are the elements 1, 4, 9 up to 100, because default value was 10. So, starting from 1 to 10 it was run, and we have got 1, 4, 9 and up to 100. So, these are this is the iteratable object that has been iterator that has been created using the this generator function squares. We can have another example for x in G, and we can print this. So, if I run this, and you can see here, and then once we have gone through this, we can again you can see for x in G we did not get any output. So, because all the elements that were part of G they have been yielded. So, therefore, in this run we did not get it. So, we will have to call it again. So, you can see G1 we are calling it again G1 squares and we are running a loop. So, the same code you can see the same code is there, just to convey this to you that generators are also function. So, in a normal function, in a regular function, you get a return value and then the call is over. In the generator function, once you get all the elements have been yielded, then that call is also over. That is why in the line number 47, that loop that we had, we did not get any output. However, once we call it again using the g1 variable here, and if I run this, you can see again, because this has been called again. So, we get the full iterator information starting from 1, 4, 9, 16 up to 100. So, if I list this g1 again, you can see this is an empty list, because all the elements have already been yielded. However, in the previously I had shown that output 46, as you can see list of g, there all the elements that were part of the iterator, they are displayed. So, it is very much like a function, but the only difference is all the elements that are there are to be yielded. Once that is done, then you won't see any output. So, you will have to call it again. So, you can see how this particular generators they actually work. Now, there is something called generator expressions. So, they are similar to list comprehension that we have discussed in previous lectures with parentheses instead of brackets. So, list comprehension they use in list comprehension we use brackets. So, because they are list and here in generator expression they are very semantically they are very similar to list comprehension, but the only thing is we use parentheses. So, let us look at one example. So, here you can see G2 and this is our generator expression. We have the this transformative expression that we have x to the power 2, then we are running a loop for x in range 10. So, let us run this and we get G2, this is generator object as you can see. So, from the generator expression we get generator object. If we look at the list of G2, you can see starting from 0, because for x in range 10 was there. So, it is started from 0. So, the elements you can see G start they do not it is not starting from 1, it is starting from 0, 1, 4 because it is 0 indexed. So, this is the output. So, generator expressions can also be really useful to perform the same thing to get the iterator. Now, they can also be this instead of list comprehension we can also use the generator expression as functional arguments. So, this is one example that we are taking, we are using some function and you can see here we are passing on generator expression as function arguments here. You can see x to the power 2 and then for x in this range. So, if I run this you can see the output. So, instead of list comprehension we can pass them generator expression as well. Let us take another example. Here you can see I am using dict function and inside dict function again we have generator expression here. So, you can see we have a tuple of I and I to the power 2 and for I in range 5. So, this tuple is then going to be passed on to the dict and will create a dict object out of it. So, if I run this you can see 0 and 0, 1 and 1, 2 and 4, second element of the tuples that we generated using the generator expression that has become value part. The first element is the key part. So, in this fashion generator expression can also be useful not just to construct a iterator, but also just also in place of list comprehensions. Now, let us talk about few more ways of creating generators. So, we have something called standard library itertools. So, this particular library has a collection of generators which can be used. So, there are a number of them there as part of this module. However, we will talk about this one function group by, which can be really useful in certain scenarios. So, what this group by function does, it takes a sequence and a function as arguments. So, two arguments, a sequence and a function, and it groups consecutive elements in the sequence by return value of the function. So, one argument is a sequence and the another argument is a function. Function is applied to each of the element of the sequence and the return value of that function and the sequence element, they are combined, they are grouped by this function. So, let us understand that through an example. So, first we need to import this module Itertools, then let us take an example of this list of strings terms 1. So, we have Ram, Ram Sevak, second value Sev Charan, Krishna, Krishna Lal. So, what we will do is we have written a lambda function here where we are returning the first letter of a given string. Now, we are running a loop. So, in that we have for later comma terms and Itertools dot group by, this is the function that we talked about, and it is taking 2 argument terms 1, this is a list of strings, and then the another function first letter, which is a lambda function. Now, it will group the elements of the terms 1 and the return value that we get after applying first letter on the elements of terms 1, and then we would be printing the same. So, if I run this, you can see we got R, that is the first letter, and you can see all the all the elements that share that first letter, they have been grouped into the list, and then capital S and then the all the all the elements string elements that had that first letter, they have been grouped. So, you can see group by. So, whatever the return value of the function, that is used as a key to group the elements of the sequences, and the same thing is has been returned. So, you can see this is this group by function, this is also in a way working as a generator here. Now, let us move on. Now, let us talk about certain other aspects which are related to errors and exception handling. So, errors and exception handling is typically required when we are looking to build or write robust programs, because certain situation might demand this, because due to human errors or some other reasons there might be certain bugs or errors in the code that we might have. So, therefore, how do we manage, how do we understand whether we have run into some error, we have run into some exception. So, for that try except blocks can be used to write some robust programs, because they in a sense will help you in terms of identifying, in terms of dealing with those errors and exceptions. So, we will talk about try and except blocks in the next lecture, where we will talk about when we do not get proper input value or proper type. So, different scenarios and how to handle those different scenarios. So, we would like to talk about this in the next lecture. So, at this point we would like to stop here itself. Thank you.